The mystery of black holes. Dear friends, in this video, I will explain about the mystery of black holes in details. I will try to cover every facts about the black holes, which you want to know. So, let's start. Black holes are among the most fascinating phenomena of outer space, and we're learning more about them all the time. Black holes are some of the strangest and most fascinating objects in space. They're extremely dense, with such strong gravitational attraction that not even light can escape their grasp. Black holes are not wormholes. Wormholes can be thought of as tunnels that connect two separate points in space and time. It is believed that the interior of black holes could contain a wormhole. The puncture is spacetime, that could offer a portal to another point in spacetime, potentially even in a different universe. How black holes are formed. Black holes are expected to form via two distinct channels. According to the first pathway, they are stellar corpses, so they form when massive stars die. Stars whose birth masses are above roughly 8 to 10 times mass of our Sun, when they exhaust all their fuel, their hydrogen, they explode and die, leaving behind a very compact dense object, a black hole. The resulting black hole that is left behind is referred to as a stellar mass black hole, and its mass is of the order of a few times the mass of the Sun. Not all stars leave behind black holes. Stars with lower birth masses leave behind a neutron star or a white dwarf. Another way that black holes form is from the direct collapse of gas, a process that is expected to result in more massive black holes with a mass ranging from 1,000 times the mass of the Sun up to even 100,000 times the mass of the Sun. This channel circumvents the formation of the traditional star, and is believed to operate in the early universe and produce more massive black hole seeds. Black holes can grow to unbelievable sizes. Black holes are measured by their size and mass, or the amount of matter they have. A medium-sized black hole may have a mass 20 times greater than the Sun. However, the pull of gravity inside a black hole is so strong that it condenses all that mass into a ball with a diameter of only about 20 miles. Supermassive black holes are the largest black holes. Professor in evolutionary science in the Department of Physics and Astronomy at Tufts, Alexander Vilenkin, said these behemoths can have a mass of 1 billion suns with a diameter about the size of our solar system. Every large galaxy, including the Milky Way, has at least one supermassive black hole at its center. As far as supermassive black holes go, ours is pretty small. It's only about a few million solar masses, he said. The smallest black hole recorded is practically petite, it's barely 4 times the mass of our Sun. Supermassive black holes. Small black holes populate the universe, but their cousins, supermassive black holes, dominate. These enormous black holes are millions or even billions of times as massive as the Sun, but are about the same size in diameter. Such black holes are thought to lie at the center of pretty much every galaxy, including the Milky Way. Scientists aren't certain how such large black holes spawn. Once these giants have formed, they gather mass from the dust and gas around them, material that is plentiful in the center of galaxies, allowing them to grow to even more enormous sizes. Supermassive black holes may be the result of hundreds or thousands of tiny black holes that merge. Large gas clouds could also be responsible, collapsing together and rapidly accreting mass. A third option is the collapse of a stellar cluster, a group of stars all falling together. Fourth, supermassive black holes could arise from large clusters of dark matter. This is a substance that we can observe through its gravitational effect on other objects. However, we don't know what dark matter is composed of because it does not emit light and cannot be directly observed. Black holes have a point of no return. Black holes have what's called an event horizon. Think of this as the surface of the black hole. Nothing can escape from under the surface, including light. So what happens when, for example, a spaceship crosses the event horizon? Let's say the spaceship sends light pulses to us as it approaches the black hole. As the spaceship approaches the event horizon, the pulses will become weaker and weaker, and the intervals between them become longer and longer, said Vilenkin. As the spaceship gets very close to the event horizon, we see it as if it's frozen. We will never see the spaceship actually go under the event horizon because light cannot escape from under there. What about the travelers in the spaceship? The Lincoln said as the spaceship approaches the event horizon, they wouldn't notice anything particular, and they would still see us. However, once they cross the event horizon, this is a point of no return. You cannot turn around and get out. You can only move towards the center of the black hole, he said. Gravity will get stronger and stronger, and since gravity stretches things in one direction, the spaceship will get spaghettified. Eventually, this spaceship will hit the central point, which is called the singularity. The singularity is, mathematically, where the gravity becomes infinitely strong, so the curvature of spacetime becomes infinite. We cannot really tell what exactly happens in singularity, but the spaceship and everything inside will be destroyed well before the ship reaches the singularity, the Lincoln said. If a star passes too close to a black hole, the star can be torn apart. Astronomers estimate that the Milky Way has anywhere from 10 million to 1 billion stellar black holes, with masses roughly 3 times that of the Sun. What would happen if you travel through a black hole? Within any black hole is the central point, the singularity, which has infinite gravity and where mass is compressed into an infinitely small point. There, it is game over. There's no surviving. And therefore the idea of traveling through time and space, by a black hole or wormhole, don't really register in reality. It is possible to survive the crossing of the horizon if you are going into a sufficiently big black hole, but there's quite some chance you'll die by hitting the black hole's singularity. If you fall straight down into a stellar black hole, you'll last a fraction of a second. For a supermassive black hole, you might last a few hours. Due to the tremendous tidal forces, an unlucky victim will suffer spaghettification, where differences in gravity from your head to your feet stretch you out. If you fell into a black hole, theory has long suggested that gravity would stretch you out like spaghetti, though your death would come before you reached the singularity. But a 2012 study published in the journal Nature suggested that quantum effects would cause the event horizon to act much like a wall of fire, which would instantly burn you to death. Black holes don't suck. Suction is caused by pulling something into a vacuum, which the massive black hole definitely is not. Instead, objects fall into them just as they fall toward anything that exerts gravity, like the Earth. If you were to stand just outside the event horizon of Sagittarius A, and you stood there for 1 minute, 700 years would pass because time passes so much slower in the gravitational field there than it does on Earth. Some have suggested that black holes could be used for time travel. When considering general relativity and special relativity, the time for an observer dilates when falling into a black hole. The closer the observer reaches the event horizon, the time dilates more. This means that 1 hour for the observer will be 100 million years for a person on Earth. Friends, I will come up with the next most mysterious facts like this. Till then, take care and goodbye.